All right, ladies and gentlemen, welcome to week number 5, day number 16. All right, so this is May the 4th. How great. All right, so we're taking a look at the do now. It says, we have detected potential flight paths of the Imperial soldiers. We need to determine which of the four doesn't belong. Which of the four doesn't belong so that our pilots can search the remaining three paths. Identify the path that does not belong and explain your reasoning. All right, so let me take a look. All right, so A, path is going this way. Okay, so that's that path. So B, looks like the path may be going down, going from left to right. C, all right, that one's going up at an arc. And D, that one's kind of riding that way. That's interesting. Okay. So the one difference I see would be that this one has kind of an arc, where the other ones are more straight lines. All right, so that's one difference that I've noted. Okay. Let's see. Let's count. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9. I got 9 dots here. I don't know if that makes much difference. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I got 11 there, points, dots with points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I got 11 points there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I got 11 points there. All right, so that's interesting. So A has only 9. B, C, D have 11. Okay, so that would be another difference. And then let's see. I don't know if I could really say there's much else different. All right, so that was a couple different ways you could look at it. I'm curious to see which one you have. And remember, when you answer, you're going to choose A, B, C, or D, and we need an explanation. Okay? All right. So now, as you work your way through, the next one is the Rebel Alliance has destroyed the Death Star. Okay, let me get a little thicker tip on here. Has destroyed this Death Star. Leia is creating a rectangular banner to welcome the forces home. The material for the banner is sold by the square foot. Leia has enough money to buy 36 square feet of material. She's trying to decide on the length and the width of the banner. Length and width of the banner. For each scenario, answer the question and justify your reasoning, which means you gotta do the math. You have to do the math. All right. If the length is 6 feet, what is the width? All right. So I'm gonna come down here. I'm gonna draw a banner. The length is 6 feet. What is the width? So let me see. So the banner is 6 feet long. Now I have 36 square feet of material. It's length and width. So we know that length times width is the area. And if our area is 36 square feet, so if I am 6 feet long, 6 times 6 is 36. So if I'm 6 feet long, I would be 6 feet wide. So we have to change this a little bit because that is really disproportional. So let me make that look more correct. So it would be, I don't know what that is. Be more like that. 6 feet, 6 feet. That would be 36 square feet. Okay, so that would be number one. Number two would be 4 feet. So it would be 4 feet this way. So let me see. So if it's 4 feet that way, so if it's 4 by 4, 4 times 4 is 16. Well, that's not it. 4 by 5 would be 20. 4 by 6, 6, 12, 24. 4 by 7, 7, 14, 28. By 8, 8, 16, 32. By 9 would be 36. So then it would be 9 this way. That's 36 square feet. Okay. So it's 3. If the length is 9 feet, what is the width? Well, that's interesting. If the length is 9 feet, then what would the width be? Well, it would be 4 feet. 9 times 4, 36. So that means that 2 and 3 are the same. That was kind of neat. So they are the same. Okay. To find the different combinations in length and width given a 36, oh, let's hold off on that. So let's move back up a little bit. For each scenario, answer the question and justify your reasoning. So that's my 1. Okay, and that's my 2. Okay, my 3 is the same. Just make it go like that. Okay. For each scenario, answer the question and justify your reasoning. So the width for number 1 would be 6 feet. The width for number 2 would be 9 feet. And the width for number 3 would be 4 feet. Okay? I'm justifying my answer because I drew it. All right, that's the strategy that I used. I did the math. Okay? 4. To find different combinations of length and width that give us the area of 36 square feet, Leah uses the equation W equals 36 divided by L, where W is the width and L is the length. Compare your strategy and Leah's methods for finding the width. How were they the same or different? Well, so I used the length times width equals area. Okay, that was the normal formula. So I took the length and the width and I multiplied them to get the area. Okay. Now, what I did do is I am actually dividing. So when I said it's, number 1 says if the length is 6 feet, well, the area, 36, divided by 6 is 6. 6 times 6 is 36. If the length is 4 feet, what is the width? Well, 36 divided by 4 would be 9. 9 times 4 is 36. And then if it's 9 feet, okay, 36 divided by 9 is 4. 9 times 4 is 36. So that is exactly as we did it. Okay, we just did more of like the guess method. Okay, so we use a little more of the guess method, but absolutely worked. Okay. Now, the next section of your activity for this week is the Dymos thing. I'm not going to do that with you. You can do that on the webpage. It is very cool. I do want to jump to the cool down with you. All right, so Unit 6, Lesson 18, cool down. Jack saves $6 each week. Ooh. Let's try it again. Zoom, zoom. Okay. Jack saves $6 each week. Let W represent the total number of weeks that Jack saves $6. Let T represent the total amount saved in dollars. So Jack saves $6 each week. Let W represent the total or the number of weeks. So let's see, if W equals 4, for example, okay, so in 4 weeks would equal T, okay, so 4 times 6, 6, 12 is 24. All right, well, this makes sense. So W is the number of weeks. W, weeks. T, total saved, $6. All right, we got this. Which graph shows the relationship between T, which is the total amount, and W, the number of weeks? All right, so let's look at A. X-axis, we have number of weeks. So at 1 week, He has $0, which is the amount saved. Well, right away I know that's not right because in 1 week he should have $6. I already know that one's wrong. Let's go to B. Number of weeks on the bottom. So this says 6 weeks. Okay. So in 6 weeks, he should have $36. That's absolutely not what that says. That's absolutely wrong. Just keep moving down. Okay. Okay. C, number of weeks at 6 weeks. Again, at 6 weeks, he should already have like $36. So his number would be all the way up here. I know that one's wrong. All right, well, A, B, and C, absolutely no way they're right. Let's make sure D is right before we just give it an okay, because we might have made a mistake somewhere in the back. So at 1 week, he's got $6. 1 week, $6. All right, that's good. 2 weeks, $12. Oh, I like that. 3 weeks, $18. 4 weeks, $24. That's because 1 times 6 is 6. 2 times 6 is 12. 3 times 6 is 18. 4 times 6 is 24. Absolutely, 100%. That is spot on. Jack saves the same amount of money each week as shown in the graph. W represents the number of weeks. T represents the total amount saved in dollars. Okay. At 2 weeks, he's got $12. 2 weeks, $12. 4 weeks, he's got $24. 6 weeks, he's got $36. Total number of weeks, total cash. Now, so I made a nice little data table. So I've taken the visual and I turned it into a data table. Okay, and sometimes we're going to ask you to do it the other way. Determine whether each statement is true. Select true or false for each statement. Jack saved a total of $12 at the end of the week. At the end of the week. The week to me means 1 week. Jack saved a total of $12 at the end of the week. Well, is that what he did? He did not. Okay, he did it at the end of 2 weeks. So I would say false at the end of 2 weeks. The equation T equals 6W. So let's see, T, let's do it over here. T equals 6W. Okay. So that's the total amount of money equals 6 times the number of weeks. So let's just do the math real quick. Okay, so here's T. 24 equals 6 times 4. 6 times 4 is 24. Hey, that works. Okay, so that one's a good one. Okay, let's try the next one. 36 equals 6 times 6. That's a good one too. All right, I'm going to say yes, that's a true. The total amount of money Jack saves depends on the number of weeks that Jack saves. The total amount of money Jack saves depends on the total or the number of weeks that Jack saves. All right, hold on, one more time. The total amount of money Jack saves, okay, that's this column, depends on the number of weeks that Jack saves. Okay, yes. If he doesn't save for 7 weeks, he's only got 6 weeks worth. All right, I'm good with that one. All right, so then justify your reasoning. All right, so Jack saved a total of $12 at the end of the week. We said at the end of 2 weeks. The equation T equals 6W. Okay, we kind of showed that. Let me zoom back up here for you. We kind of showed that up here. That's what we did. And then yes And I had shown that up here too. Okay. All right, guys. Hopefully that helped. May the 4th be with you. See you guys.